Welcome. Today we are discussing a critical component of safety in our industry, protecting the core through Ingress Protection, or IP, for instruments in oil and gas. Our goal is simple: ensuring the safety and reliability of the instruments that power our operations. Often, we focus on the large mechanical equipment, but the delicate sensors and switches are the eyes and ears of the plant. If they fail, the system fails. In this video, we will explore what IP ratings are, why they are vital in our specific environment, and how to choose the right protection to prevent downtime and accidents. Let's protect the core of your operation. So, what is Ingress Protection? The IP rating is an international standard, specifically IEC 60529. It moves us away from vague marketing terms like waterproof and gives us a clear, testable measure. Specifically, the IP rating classifies the level of protection an electrical enclosure provides against two things: solids and liquids. Solids include intrusions like dust, dirt, and even accidental contact with hands or tools. Liquids include moisture, water jets, and chemicals. It is a simple, standardized way to define exactly how well a box protects the electronics inside it. Why do we care so much about this standard? Because the oil and gas challenge is an unforgiving one. Our equipment is situated in some of the most hostile environments on Earth. The stakes here are incredibly high. We aren't just talking about a broken switch that costs a few dollars to replace. Instruments in this industry face extreme weather, corrosive salt spray on offshore rigs, abrasive sand in the desert, and dangerous chemical vapors in refineries. If a sensor fails because water got inside, it doesn't just mean downtime, though downtime is expensive. It can lead to catastrophic events. A short-circuited switch could fail to trigger a safety shutdown, leading to fires, explosions, or toxic leaks. Remember, these operations run 24/7. The equipment must be highly reliable because the environment never takes a day off. Let's break down the specific environmental enemies we face in the field. First, we have dust and sand. In desert operations, fine particles can infiltrate enclosures and clog delicate mechanical parts or bridge electrical circuits. Then there is water. This comes in many forms. We have water jets, often from high-pressure washdowns used to clean rigs and equipment. We also have immersion hazards, where equipment in flood zones or subsea applications faces temporary or continuous submersion. Beyond solids and liquids, we battle corrosion. Salt spray and chemical-laden moisture can eat away at enclosures, compromising the seals over time. And finally, extreme temperatures. From frozen pipelines in the Arctic to the scorching desert heat, thermal expansion and contraction can degrade seals, opening the door for ingress. There is a critical distinction every engineer must understand: the difference between IP and X ratings. The IP rating stops dust and water from getting in. It is about environmental protection. The X rating, like ATEX or IECX, is different. It stops the instrument from causing an explosion in a flammable atmosphere. Here is the key message: an enclosure can be IP68, fully waterproof, but not be explosion-proof. In a hazardous zone, you cannot choose one or the other. You need both the correct IP rating and the correct X rating to operate safely. Let's decode the rating itself. The code consists of the letters IP followed by two digits, X and Y. The first digit, X, represents protection against solids. This ranges from 0 to 6. The second digit, Y, represents protection against liquids. This ranges from 0 to 9K. The general rule is simple: the higher the number, the better the protection. By reading these two digits, you know exactly what environmental threats the enclosure can withstand. Let's break down what those numbers mean. Let's zoom in on that first digit: solids protection ranging from 0 to 6. At 0, there is effectively no protection. Levels 1 through 4 are about preventing objects from entering. IP1 protects against large objects like a hand. IP2 protects against fingers. IP3 protects against tools like screwdrivers. And IP4 stops wires and ants larger than 1 millimeter. But in oil and gas, we are usually worried about the top of the scale. IP5 is dust protected. Dust might get in, but not enough to stop the machine from working. IP6 is the gold standard, dust tight. This means absolutely no dust can enter the enclosure, even after hours of exposure. For desert environments or areas with fine catalyst dust, IP6X is usually the requirement. Now the second digit, liquids protection. This is where it gets interesting, because water attacks in different ways. Level 1 is just dripping water. Level 4 protects against splashing water from any direction. As we move up, the pressure increases. IP5 protects against water jets from a nozzle. IP6 handles powerful water jets. Think heavy seas breaking over a deck. Then we enter the immersion ratings. IP7 allows for temporary submersion, like dropping a tool in a shallow pit. IP8 protects against continuous submersion, crucial for subsea equipment. Finally, at the very top, we have IP9K. This is protection against high temperature, high pressure steam cleaning. If you are steam cleaning grease off an instrument, you need this rating. With all those numbers, which ones actually matter for us? Based on industry best practices, we generally focus on 4 key ratings. First is IP65. This is dust tight and protects against low pressure water jets. It's good for general outdoor equipment that isn't going to be blasted with a hose. Next is IP66. This is a very common standard for offshore. It is dust tight and protects against powerful water jets. This is ideal for on-deck equipment exposed to heavy seas or washdowns. Then we have IP67, dust tight plus temporary immersion. This is perfect for junction boxes located in pits that might flood during a heavy rainstorm. And finally, IP68, dust tight and continuous submersion. This is for permanently wet locations or subsea instruments. Choosing from these 4 covers 99% of our needs. If you like our video, please subscribe, and share with your friends. If you are working with equipment from North America, you might see a NEMA rating instead of IP. It is important to know the difference. IP is the international IEC standard. It strictly focuses on solids and liquids. NEMA ratings, used in the US, cover solids and liquids too, but they go a step further. They define protection against corrosion and construction standards, like gasket quality. Here is a rough conversion. A NEMA 4X enclosure is similar to IP66, but the X in NEMA 4X specifically signifies corrosion resistance. In offshore environments, that corrosion resistance is vital. So while IP ratings tell you if water gets in, NEMA ratings tell you if the box itself will survive the salt spray. Which instruments need this protection? Practically everything in the field. It starts with pressure transmitters and temperature sensors monitoring the process. It includes flow meters and critical safety devices like gas detectors and level switches. Don't forget the infrastructure: junction boxes, valve actuators, and local control stations. Every single one of these devices represents a potential failure point if water or dust gets inside. They all require the appropriate IP rating. Let's look at real-world applications. Upstream, on an offshore rig, equipment is battered by salt spray and waves. Protecting instrumentation here is crucial for safety. Midstream, pipelines face wind-blown sand and extreme temperature swings. Protection ensures reliable transport operations. Downstream, in refineries, hazards include chemical vapors and high-pressure steam cleaning. Here you might need IP69K for steam cleaning, and you absolutely need the correct EX rating for explosion prevention. What is the cost of getting this wrong? It's a chain reaction. It starts with a failed seal. Perhaps a degraded gasket lets in moisture. This causes an instrument short circuit, bridging a terminal block. This leads to a false reading. The control room might see a normal level while a tank is actually overflowing. The consequence? A toxic release, a fire, or a catastrophic explosion. The wrong rating is not just a maintenance headache, it is a major safety risk. To choose the right protection, follow these 3 steps. Step 1. Assess the hazard. Is it an explosive atmosphere? This defines your X rating requirement first. Step 2. Assess the environment. Will there be dust, rain, or submersion? This defines your necessary IP rating. Step 3. Assess the material. Do you need resistance to salt spray or chemicals? This determines if you need stainless steel or other specialized materials. This logic ensures you cover all bases. Finally, remember that maintenance is non-negotiable. An IP rating is only valid if the device is maintained. You must regularly inspect gaskets and seals for cracks or damage. Check the enclosure body for rust that could compromise the rating. Most importantly, ensure cable glands are properly installed and tightened, and always seal unused cable entries with certified plugs. If you leave a hole open, the rating is gone. To conclude, in the oil and gas industry, protection is not an option. IP ratings give us a standard, testable measure of protection. For us, ratings like IP66, 67, and 68 are the most common and critical. But remember, IP is not X. You need both. The right rating is non-negotiable for safety and compliance. By understanding these standards and maintaining your equipment, you safeguard your assets and prevent catastrophic failure. Thank you for watching another video with us. If you found this video helpful, please like, share, and subscribe for more content on instrumentation and control engineering. If you have any questions, please leave them in the comments section below, and we'll do our best to answer them. Thanks again for watching.